prenatal development. Introduction. In this study session, discussion shall be on how conception normally occurs and the stages of prenatal development. We will also examine the importance of prenatal care and explain fetal discrimination. Learning outcomes. When you have studied this session, you should be able to 1. Explain how fertilization takes place. 2. Describe the prenatal stages of human development. 3. Give reasons why good prenatal care is important. 4. Explain fetal discrimination. 5. Explain fetal learning. And 6. Give examples of factors that could constitute risk for the developing child. How fertilization takes place. Every human being begins with a single spermatozoon, one of millions of sperm cells from the father joins an ovum, one of the several 100,000 ova produced by the mother's body. Fertilization or conception is the process by which sperm and ovum, the male and female gamete respectively, or sex cells, combine to create a single cell called a zygote, which then duplicates itself again and again by cell division to become a baby. A girl is born with all the ova she will ever have, about 400,000. At birth, these immature ova are in her 2 ovaries, each ovum in its own small sac or follicle. The ovum, which is only about 1/4 the size of the period that ends this sentence, is the largest cell in the human body. In a mature woman, ovulation, which is the rupture of a mature follicle in either ovary and expulsion of its ovum, occurs about once every 28 days until menopause. The ovum is swept along through the fallopian tube by tiny hair cells called cilia towards the uterus or womb. Fertilization normally occurs during the brief time the ovum is passing through the fallopian tube. The sperm, which meets the ovum, has tremendous implications for the new person. The tadpole-like sperm, only 1/60,000 inch from head to tail, is one of the smallest cells in the body. Sperm are much more active than ova, and there are many more of them. Sperms are produced in the vesicle, testis, or reproductive glands of a mature male at a rate of several 100 million a day, and are ejaculated in the semen at sexual climax. They enter the vagina and try to swim through the cervix, that is the opening of the uterus, and into the fallopian tubes, but only a tiny fraction make it that far. Stages of prenatal development. If you had been born in China, you would probably celebrate your birthday on your estimated date of conception rather than your date of birth. This Chinese custom recognizes the importance of gestation, the approximately 9-month or 266-day period of development between conception and birth. Scientists also date gestational age from conception. What turns a fertilized ovum or zygote into a creature with a specific shape and pattern? Research suggests that an identifiable group of genes is responsible for this transformation in vertebrates, presumably including human beings. These genes produce molecules called morphogenes, which are switched on after fertilization and begins sculpting arms, hands, fingers, vertebrae, ribs, a brain, and other body parts, according to Cross, Concordet, and Ingham, 1993. Prenatal development takes place in 3 stages: germinal, embryonic, and fetal. During these 3 stages of gestation, the original single-celled zygote grows into an embryo and then a fetus. Both before and after birth, growth and motor development proceed according to 2 fundamental principles. The cephalocaudal principle, from Greek and Latin meaning head to tail, dictates that development proceeds from the head to the lower part of the body. An embryo's head, brain, and eyes develop earliest and are disproportionately large until the other parts catch up. At 2 months of gestation, the embryo's head is half the length of the body. By the time of birth, the head is only 1/4 the length of the body, but is still disproportionately large. Secondly, according to the proximodistal principle, from Latin near to far, development proceeds from parts near the center of the body to outer ones. For example, the embryo's head and trunk develop before the limbs, and the arms and legs develop before fingers and toes. Now let's take the stages one after the other. Germinal stage, fertilization to 2 weeks. During the germinal stage, the fertilized ovum divides and becomes more complex, and the growing organism is implanted in the wall of the uterus. Within 36 hours after fertilization, the one-celled zygote enters a period of rapid cell division and duplication, or mitosis. 72 hours after fertilization, it has divided into 16 to 32 cells. A day later, it has 64 cells. This division continues until the original single cell has developed into the 800 billion or more specialized cells that make up the human body. While the fertilized ovum is dividing, it is also making its way down the fallopian tube to the uterus. A journey of 3 or 4 days. Its form changes into a fluid-filled sphere, a blastocyst, which floats freely in the uterus for a day or 2 and then begins to implant or embed itself in the uterine wall. As cell differentiation begins, some cells around the edge of the blastocyst cluster on one side to form the embryonic disc, a thickened cell mass from which the embryo begins to develop. This mass is already differentiating into 2 layers. The upper layer, the ectoderm, will become the outer layer of the skin. The nails, hair, teeth, sensory organs, and the nervous system, including the brain and spinal cord. The lower layer, the endoderm, will become the digestive system, liver, pancreas, salivary glands, and respiratory system. Later, a middle layer, the mesoderm, will develop and differentiate into the inner layer of skin, muscles, skeleton, and excretory and circulatory systems. Other parts of the blastocyst begin to develop into organs that will nurture and protect the unborn child: the placenta, the umbilical cord, and the amniotic sac. The placenta, which has several important functions, will be connected to the embryo by the umbilical cord. Through this cord, the placenta delivers oxygen and nourishment to the developing baby, and removes its body waste. The placenta also helps to combat internal infection and gives the unborn child immunity to various diseases. It produces the hormones that support pregnancy, prepare the mother's breast for lactation, and eventually stimulate the uterine contractions that will expel the baby from the mother's body. The amniotic sac is a fluid-filled membrane that encases the developing baby, protecting it and giving it room to move. The trophoblast, the outer cell layer of the blastocyst, which becomes part of the placenta, produces tiny thread-like structures that penetrate the lining of the uterine wall and enable the developing organism to cling there until it is fully implanted in the uterine lining. Embryonic stage, 2 to 8 weeks. During the embryonic stage, the second stage of gestation, from about 2 to 8 weeks, the organs and major body systems, respiratory, digestive, and nervous, develop rapidly. This is a critical period when the embryo is most vulnerable to destructive influences in the prenatal environment. An organ, system, or structure that is still developing at the time of exposure is most likely to be affected. A structure or organ that is already formed is in least danger. Defects that occur later in pregnancy are likely to be less serious. The most severe defective embryos usually do not survive beyond the first trimester or 3-month pregnancy period. A spontaneous abortion, commonly called a miscarriage, is the expulsion from the uterus of an embryo or fetus that is unable to survive outside the womb. Most miscarriages result from abnormal pregnancies. About 50 to 70% involve chromosomal abnormalities. Males are more susceptible than females to the effect of prenatal shocks and are more likely to be spontaneously aborted or stillborn, dead at birth. Thus, although about 120 to 170 males are conceived for every 100 females, a fact that has been attributed to the greater mobility to sperm carrying the smaller Y chromosome. Only 106 boys are born for every 100 girls. Males' greater vulnerability continues after birth. One of them die early in life, and at every age they are more susceptible to many disorders. Part of the explanation for male vulnerability may be all zygotes start out with a female body plan. The fact that males undergo more alteration than females during early development may account at least in part for their poorer survival rate. Other possibilities are that the Y chromosome may contain harmful genes, or that the sexes may have different mechanisms for providing immunity to infections and diseases. Women are at higher risk of miscarriage if they smoke, drink alcohol or coffee, have miscarried in the past, experience vaginal bleeding during pregnancy, are over 35, or have uterine abnormalities, endocrine problems, or certain infections, according to Michelle, 1993. The physical risk to a woman who has a miscarriage are small, but an infection, a hemorrhage, or an embolism, obstruction of blood vessel, can sometimes occur. Women over 29 and those who miscarry in the second trimester are more likely to experience such complications, as are women who have limited access to health care, such as women and members of minority groups, according to Abgar and Koge, 1993. Consider this tip. Growth and development both before and after birth follow the cephalocaudal principle from top to bottom and the proximodistal principle. About 1/3 of all conceptions end in spontaneous abortion, miscarriage. Nearly all birth defects and 3 out of our miscarriages occur in the first trimester of pregnancy. Males are more likely than females to be spontaneously aborted. Fetuses interact actively with their environment within the womb. As they grow and mature, they move less, but more vigorously, and show changes in heart rate, cardiac response, and coordination of sleep-wake states. Fetuses appear to be able to hear, exercise sensory discrimination, learn, and remember. Fetal stage, 8 weeks to birth. With the appearance of the first bone cells at about 8 weeks, the developing baby is in the fetal stage, the final stage of gestation. During this period, the fetus grows rapidly to about 20 times its previous length, and organs and body systems become more complex. Right up to birth, finishing touches such as fingernails, toenails, and eyelids develop. Fetuses are not passive passengers in their mother's wombs. They respirate, kick, turn, flex their bodies, do somersaults, squint, swallow, make firsts, hiccups, and suck their thumbs. All these activities do not occur in a vacuum. Although the amniotic fluid provides a protective buffer, the fetus is surrounded by and interacts with a complex environment bounded by the flexible uterine walls and the amniotic sac. Smotherman and Robinson, 1996, page 426. These elastic membranes restrain the fetus but also stimulate some kinds of movement. The fetus isolation in the womb and dependence on the mother's body make it easier to study the effects of specific kinds of stimulation. Much of this research has been to study the effects of specific kinds of stimulation. Much of this research has been done with the pregnant rats. Human fetuses can be observed by ultrasound, a medical procedure using high-frequency sound waves to detect the outline of a fetus and observe its movement. New instrumentation allows the monitoring of a fetus' heart rate, changes in activity level, states of sleep and wakefulness, and cardiac reactivity. Through such technologies, scientists have learned much about fetal development. In one study, 34 healthy fetuses were monitored at 4-week intervals from 20 weeks of gestation until term. As time went on, they had slower but more variable heart rates, possibly in response to the increasing stress of the mother's pregnancy, and greater cardiac response to stimulation. They also showed less but more vigorous activity, perhaps a result of the increasing difficulty of movement for a growing fetus in a constricted environment, as well as of maturation of the nervous system. A significant jump in all these aspects of fetal development seems to occur between 28 and 32 weeks and may reflect an advance in brain development. It may also help explain why infants born prematurely at this age are more likely to survive and flourish than those born earlier. Even inside the womb, each individual is unique. The movement of fetuses differ, and their heart rates vary in regularity and speed. There are marked individual differences in activity level, and there are gender differences too. One study using a fetal electrocardiograph, which can detect even very slight movement changes, found that male fetuses are more active and tend to move vigorously than female fetuses throughout gestation, even when they are same size. This finding suggests that infant boys' tendency to be more active than girls may be at least partly inborn, according to Di Pietro, Hodgson, Costigan, Hilton, and Johnson, 1996. Women who bear more than one child often notice differences in fetal activity from one pregnancy to another. One fetus kicks or punches, another squirms, and still another makes sharp, spasmodic movements. Such differences may predict how active, restless, or resistant to handling a baby will be during the first year. Sontag, 1966. Some of these patterns seem to persist into later childhood and adulthood, supporting the existence of inborn temperament. In one study, apparent differences in temperament appeared as early as 24 weeks of gestation and remained stable throughout the prenatal period and 3 to 6 months after birth. Infants who had moved around more in the womb tended to be more difficult, unpredictable, and active and less adaptable, according to their mothers, than infants whose fetal activity had been calmer. It is possible, however, that the mothers' reports about their infant temperaments were influenced by perceptions formed during pregnancy. Attempts are now underway to confirm these findings with laboratory-based assessments. Fetal sensory discrimination. Beginning at about the 12th week of gestation, the fetus swallows and inhales some of the amniotic fluids in which it floats. This stimulation may affect the body's senses of taste and smell and may contribute to the development of the nose, tongue, palate, lungs, and other organs needed for breathing and digestion. Again, this process is not passive. The fetus' respiration, digestion, and elimination regulate the amount and composition of the surrounding amniotic fluid. This fluid also contains chemical substances that cross the placenta from the mother's bloodstream and enter the fetus' bloodstream. All of these sensations and experiences may help shape the development of body and brain. Mature taste cells appear at about 14 weeks of gestation. The olfactory system, which controls the sense of smell, is also well developed before birth. The flavors and odors of foods the mother consumes may be transmitted to the fetus through the amniotic fluid. It is not yet clear whether the human fetus responds to odor, but rodent fetuses do. Whether odor preferences in the womb are related to preferences after birth also remains to be determined. Prenatal experience does not seem to significantly affect taste preferences, which seem to be largely innate. Fetal learning. A fetus is continually exposed to other kinds of sensory stimuli, including the mother's voice and heartbeat and the vibrations of her body. Fetuses respond to these stimuli, showing that they can hear and feel. Studies going back at least 60 years show that human fetuses as early as 7 months of gestation respond to bells and vibrations and can discriminate between different tones. In one experiment, researchers turned on a handheld vibrator and put its tip to the mother's abdomen, just over the place where the fetus head was, as confirmed by ultrasound. Then they measured fetal heart rate and movement, again with ultrasound. After testing 60 fetuses, they found that the first responses to sound and vibration came at 26 weeks of gestation. Response increased steadily over the next 6 weeks and reached a plateau at about 32 weeks. Fetal exposure to sounds, including speech sounds, may spoil the ability to process such sounds after birth. Familiarity with the mother's voice may have an even more basic function to help newborns locate the source of food. Hungry infants, no matter on which side they are held, turn toward the breast in the direction from which they hear the mother's voice. Noirot and Algeria, 1983, cited in Roviculia, 1996. The fact that fetuses can discriminate what they have heard shows that they can learn and remember. Experiments have found that newborns 2 to 4 days old prefer musical and speech sequences heard before birth. They also prefer their mother's voice to those of other women, female voices to male voices, and their mother's native language to another language. See Moon, Cooper, and FIFA, 1993. Environmental hazards. Recently, scientists have become aware of some of the myriad environmental influences that can negatively affect the developing organism. The pervasive influence of the prenatal environment underlies the importance of providing an unborn child with the best possible start in life. The role of the father used to be virtually ignored. Today, we have known that various environmental factors can affect a man's sperm and the children he conceives. Although the mother's role has been recognized far longer, researchers are still discovering environmental hazards that can affect her fetus. The fetus can be greatly affected by its prenatal environment. Some environmental factors are teratogenic. The likelihood of birth defects may depend on the timing and intensity of an environmental event and its interaction with genetic factors. Important environmental influences involving the mother include nutrition, physical activity, smoking, drinking, intake of other legal or illegal drugs, transmission of acquired immune deficiency syndrome, AIDS, or maternal illnesses or infections, maternal age, incompatibility of blood type, and external environmental hazards such as chemicals and radiations. Good prenatal care is therefore essential for healthy development. It can lead to detection of defects and disorders, and especially if begun early in a pregnancy, can reduce maternal and infant death, low birth weight, and other birth complications. Some of these findings have led to ethical debates over a woman's responsibility for avoiding activities that may harm her unborn child. Good prenatal care can give every child the best possible chance of entering the world in good condition to meet the challenges of life outside the womb. Study session summary. In this study session, you learn that prenatal development is a genetically directed process that occurs in 3 stages of gestation: the germinal, embryonic, and the fetal stage. We noted that the prenatal environment of the fetus plays an important role in its development. End of study session 8. Thank you for listening.